Alrighty guys, so today we're going to talk about the Algebra 2 Topic 1 test. Just so you know, this video is meant to be watched and paused to catch up on if you fall behind on taking these notes. I apologize for any sniffling you might hear or any creaks that my chair makes. With that being said, let's get started. The difference between functions and non-functions. Functions have exactly one output for every single input, and they pass the vertical line test, so it crosses once only. Non-functions fail the vertical line test. What this means is you can have one input lead to two different outputs. So if you have, like, for example, f of 2 equals 4 and f of 2 equals 6, this will result in it failing the vertical line test graphically, and it means that it's not a function because it'll cross more than once if you draw a vertical line anywhere on that graph. Once again, for the vertical line test, you can draw that line anywhere for it to be valid. So this also fails right here. And for this graph over here, you can draw that vertical line anywhere and it will always pass that test. It should only cross once for it to be a function. All right, so as I go over these notes, I will be referencing some screenshots from Desmos. Just know that during the test, you may at any point in time type into Desmos these functions and take a look at them. So let's start at the beginning. Let's go. 1-1, relations and functions. We have to determine whether these are a function or not. So the answer would be either yes or no. For the first one, if you keep track of the inputs, you'll see that none of the inputs repeat. Like, none of these numbers are the same. So that's a good sign that it is a function. And if you graph it on Desmos, you'll see that it will pass the vertical line test. It doesn't matter where I draw that line. It's only going to cross once. So it does pass that test. The second function, however, when I type in number 2 into Desmos, I type in number 2 and take a look at this. I have f of 4 equaling 5 and f of 1 equaling 5. So this tells me that it's not a function. And it does fail the vertical line test right here. That is a failure. So this would not be a function. Once again, the difference between those two is you can draw a vertical line anywhere on the first one and not have it cross twice. That makes it a function. So for number 1 and number 2, this would be a yes, and this would be a no. The next ones are more straightforward. I'll leave these up to you to answer that. Here we have a little bit of a suspicious vertical line for you to interpret. And the second one looks very much like a parabola. So, interpret that as you will. I'll let you answer number 3 and number 4 on your own, using your own eyeballs. Moving on. Find f of -2 and f of 3 for each function. Sorry about my chair noise. So this one, you can do it by hand. If you wanted to just plug it in, you can plug in for x, -2. That's literally what we're doing, is we're plugging in -2 for x. So f of -2 would be equal to plug in -2 plus 4. -2 would be +2 plus 4 would give me 6. However, if you're feeling lazy, you may hop right over to Desmos, type the function in, and get an answer straight away. So over here on Desmos, I've typed in the function to begin with. You have to type in the function for this to work. And then all I did was type in f of -2, which gave me 6. You can also calculate it. You can use it just like a calculator. And you can see it on the graph as a point. So it should be a point on the line or whatever function that you have. So once again, that's number 5. For number 6, once again, you can do it by hand, but for number 6, I just went ahead and typed it into Desmos, plugged in f of 3, and I got 29. So in general, I would use Desmos because it's really straightforward. If you're given a function and you want to know what is f of whatever input that you want, there's a really easy way to get that. So I got 29 for that. Please keep in mind that you do need to find both for both functions. So I did not give you the full answer for 5 and 6. So you do need to find both for both functions. Number 7, for this one, they want us to find the domain and range using inequality notation. So we're going to be using these symbols, less than and greater than. The first one you should recognize from Algebra 1 is a linear function. If you have a function that is in this form of any type, this means that it's linear. And this means that the domain and range is going to be all real numbers for both the domain and the range. The reason for this is because it's a line. It's going to continue off infinitely in both directions. So we don't even have to go look at Desmos. We know that this is going to look like a line. So we know that both the domain and range have to be all real numbers. For number 8, let's pretend like you don't know what this looks like. So for number 8, let's say that you type this in to Desmos. So for number 8, we type in negative x squared. And we notice that the graph continues on forever in these two directions, which means it goes all the way to the left to negative infinity, all the way to the right to positive infinity. So that means my domain is going to be all real numbers. However, my range will not be all real numbers. In fact, we can see that there is a maximum right here at 0, at y equals 0. So if we have a maximum right there, we know that the range goes from negative infinity on the y-axis to 0. The way to write that is we would write x is less than or equal to 0. So for number 8, that's what I would put for the domain and range. For number 9, similarly, I just typed it in. Or did I? Yeah, I did. Number 9, I just typed it in. Y equals 1 over x. Once again, we're looking for the domain and the range. And if we're looking left to right, so we can see that the graph continues this way to negative infinity. It kind of skips past 0, and then it continues to the right all the way to positive infinity. We would call this a gap at 0. So here's how we would describe that gap. We would say that x is greater than 0 and x is less than 0. Notice that we're not including 0, otherwise we would have used these two symbols. But since 0 is not included, we would say it's greater than 0 and less than 0, meaning that, something like 0.1 is in the set, but something like 0 is not. The range is very similar. It continues from negative infinity down here all the way to positive infinity with a gap at 0. And since we have this gap here, and since we're talking about the range, it's going to be essentially the same thing, except this time we're going to use the letter y since we're talking about range. Y is greater than 0 and y is less than 0 for the range, and that's up and down. Just as long as you consider domain left and right and range up and down, you shouldn't be having any struggles, especially if this is a multiple choice question on the test. Let's see, for number 10. Find the maximum values for each function on the given interval if each value exists, minimum and maximum. For this, I'm going to be only finding the maximum. So that means you will have to find the minimums on your own. But for this video, I will find the maximums with you. Remember that for minimum and maximum, you're talking about the y value. So if we take a look at these graphs on Desmos, between these intervals, remember that the interval is your x values, your inputs. So when I go graph this on Desmos, I'll show you what I mean. Number 10, okay, my interval was between 2 and 23. So I typed in x equals 2 and x equals 23. And these gave me these two red and green lines, and these are my boundaries. For the maximum value, I noticed that the highest value in this range is right here at 12,167. So that is literally the maximum for this interval. You will have to go look for this graph yourself to find out what this point is. This would be your minimum, but I'll leave that up to you to find for yourself. Similarly, on number 11, we had the interval between, negative 3 and 0. So I type in x equals negative 3 and x equals 0. I just typed in the function just straight up off the paper, and I'll actually give you the minimum and maximum for this one. So the maximum would be right here at negative 2.5, and the minimum would be right here at negative 4. You just have to answer that question in the space provided on the review. Okay, moving on. State the domain and range using interval notation. So let's see. This is going to be using the brackets and parentheses instead of the less than or greater than. For the first one, this is a parabola, so it continues up to positive infinity forever, but it stops right here at 1. So that would be the range. And then the domain, well, it continues to the left and to the right forever. So the domain would be all real numbers, or how we would put that in interval notation would be all real numbers, just the R with this line through it. The range is going to be between 1 and infinity. So using interval notation, we would use 1, since this is a closed circle, not an open circle. So a bracket for 1, comma, infinity. And we always use parentheses for infinity. For the second graph, it's kind of the same shape, even though it's a V instead of a U. It's kind of the same idea where these arrows continue on forever. So it's the same idea. So the domain's going to be the same. The domain's going to be all real numbers. And the range, it's going to be everything less than positive 1. So instead, we would write from negative infinity to 1, with 1 included with a bracket, since that's a closed circle. Okay, the next part's going to take a lot out of me, so let's pause the recording. All right, function operations. So we take two functions and we combine them in some way. We can either add, subtract, multiply, or divide. And we'll also be composing functions, and that's with the open circle. So just know that those are the 5 operations that we can do. I've tried to color code these the best I can, and I'll try to use that color coding scheme for the rest of this, just to make sure everything's super clear. G of x plus f of x. So for this, we're just going to literally take whatever g of x is. In this case, it's x squared plus 2. And we are going to add whatever f of x is, which is negative x plus 1. If we simplify everything out, we get x squared plus 2 minus x plus 1. And now we just need to combine like terms. This would be x squared minus x plus 3. So that would be your final answer for that one. So basically, you just combine them in whatever way that they say. In this case, they said addition, so I just added them. And then simplify until you get something that has, all like terms combined and all parentheses gone. For number 15, we're going to take g of x minus f of x. It's going to be a pretty similar thing, so I'll just leave the other one up because it's going to help us here. Copy it down. We got x squared plus 2, and this time we're going to subtract. And I'm going to use parentheses here just to make sure I don't mess anything up. Subtract negative x plus 1. When you do this, you do have to distribute the negative. So we're going to end up with x squared plus 2 plus x. Okay, negative times a negative gives you a positive. Minus 1. Just combine like terms, and we will get a final answer. So x squared plus x plus 1. Because I got positive 2 minus 1 to get the plus 1. All right, moving on to multiplying. So for this one, we're going to have to use the box. So hopefully you remember that from previous adventures in algebra. So let's see, g of x times f of x. We're going to take, in parentheses, x squared plus 2 times f of x, which is negative x plus 1. Okay, to multiply these two things together, you're going to need a box. Can I move that? Dang it. Oh, how embarrassing. Okay, you're going to need a box. In that box, we're going to need to put the two things that we're multiplying on the outside. So x squared plus 2, and then we have negative x plus 1. And we multiply straight across. So for example, this box, we would take negative x times x squared to get negative x to the power of 3. We would take negative x times 2 to get negative 2x. X squared times 1 would be x squared, and 1 times 2 would just be 2. Since none of these are like terms, I'm literally just going to add them all up. So it's going to be a negative x cubed plus x squared minus 2x plus 2. And since all of these are not like terms, it's fully simplified, I am now done. So just a little bit of box, and we're totally good. The next one, I'll be honest, I don't know what's going to happen with this one, so we're just going to find out together. We're literally just going to take a fraction, and we're going to do what it says. It says on the top, put f of x. It says on the bottom, put g of x. So that's literally all we're going to do. On the top, we'll put, let's see. I color-coded these wrong, didn't I? F of x. G of x, I've been doing red. Yeah, I did it the other way. Excuse me. Okay, on the top, we'll put negative x plus 1. on the bottom, we will put x squared plus 2. And for the purposes of my class, that's literally it. That's all you do. Any questions? We'll move on after that one. So for the purposes of my class, we'll say that's good right there. That's your answer. Fully simplified in my books. Now composing is where things get interesting. So you need to literally use your inputs and outputs appropriately. I'm going to rewrite down f of x and g of x just so we have them handy. Negative x plus 1, and then g of x equals x squared plus 2. Okay, and we have to identify what our inside function is and what our outside function is. Sorry about the chair noise. I'm going to adjust my seat. Sorry about the noise. My chair is like 10 years old. Okay, f of g of x. F of x is my outside function. My inside function is what I'm going to plug in. So if we were to write this out, we would say this is equal to my outside function, which is negative x plus 1. And what you'll notice what I did is instead of putting x here, I've left a blank. Okay, in that blank, I'm going to put my inside function, which is g of x. In g of x, I have x squared plus 2. We distribute the negative, okay, because same theme here. We're just trying to simplify once we've done this. We have negative x squared minus 2 plus 1. This would be equal to negative x squared minus 1 after we combine those like terms. And this would be the fully simplified result if you take f of g of x, f composed of g of x. Okay, it's really important to differentiate what your outside function is versus what your inside function is. So make sure you're differentiating those two things. We'll make sure to emphasize that on this next one here, and I'll leave them side by side. If we were to find g of f of x, this would be equal to g of x, which is x squared plus 2. But since I'm composing, I'm not going to write x. I'm just going to simply put a blank. Instead of x, I will simply put a blank, and in the blank, I will put f of x, my inside function. F of x is negative x plus 1. And we need the box again. The reason we need the box is because anything squared is just that thing times itself. So this is essentially the situation we have. And I'll zoom in here so we can finish this off. Let's see. We're going to need a box where we're going to take negative x plus 1 times negative x plus 1. Draw my lines here, and we'll just start multiplying and see what happens. We have negative x times negative x, which is positive x squared. We have negative x times 1, which is negative x. Same thing on the bottom left here, negative x as well. And then we have 1 times 1, which is just 1. Okay, if we add up everything inside, we get x squared minus x plus 1 plus 2. We got to remember to carry the 2. Okay, don't forget about the 2. If we combine our like terms, we get x squared minus 2x plus 3. And that would be your final answer for g of f of x. Once again, looking at these side by side, it's just important to differentiate what your outside function is and what your inside function is. Okay, as long as you can tell those two things apart, you can plug them into each other without any issue whatsoever. Let's talk about inverse functions, and then hopefully we'll be almost done with this. Once again, pause at any time if you're taking notes or going over this. A couple of properties. For this one, I'm going to use a parabola. As I'm going to explain later, if you have an inverse function, it's going to look pretty similar to the original. However, it doesn't always have to be a function. So here we have, excuse my chair, here we have a function that passes the vertical line test by only crossing once. So it passes. And here we have f inverse, which does not pass the vertical line test. It crosses twice. So this is not a function. So it's not always the case that if you have a function that when you take the inverse, you will still have a function. Also true about inverse functions. If you have your inputs going to your outputs via some function, f of x, the way to take those outputs back to the inputs is by having an inverse function, f inverse of x. That's essentially what it says right here. If you have f of a is equal to b, then f inverse of b is equal to a. If we use real numbers, we could say that f of 1 equals 3, then f inverse of 3 is equal to 1. So inputs go to outputs. When you do that, it creates a lot of symmetry on the graph. So here we have f of x and f inverse of x. Because of the symmetry that goes on, like for example, if I switch the coordinates of f of x, I have 0, 1 right here, and then I have 1, 0 on f inverse. So we can see that these two graphs are very symmetrical, and they're actually specifically symmetrical about the line y equals x, which is the exact diagonal across the axes. So that line should always give you some symmetry if you have inverses. Okay, so that line is y equals x. And if you're doing this on Desmos, you would want to type in all three of these to see if they're inverses, just to make sure, because if they don't look symmetrical, then that's a big clue that they might not be, which we'll get to later. To determine further if functions are inverses, we have a test. What we can do is we can say, we can take f of g of x or g of f of x, otherwise saying we can compose the two functions. And if they give you x, then we know that they are inverses. Okay, so let me write that out here. If f of g of x equals x, they are inverses. So we're trying to answer yes or no. So what we have to do is we have to take f of g of x. Where g of x is my inside function. This would be equal to my outside function, 1/3 x plus 2. But you'll notice, once again, instead of writing an x, I've left a blank. In that blank, I will put my supposed inverse function, g of x. I will put 3x minus 6. After some simplifying, we will find out what we get. This is equal to, well, let's see, let's distribute the 1/3. Okay, and off to the side, I'll do my little calculations. We have 1/3 times 3x. Well, this equals 1x, since these 3's are going to cancel out. Next thing that we have is 1/3 times negative 6. Well, this is going to be a negative answer since we have a positive times a negative. And if you take 1/3 times 6, you get 2. So this would be negative 2. So x minus 2 plus 2. I just carry it down. It's just coming with us. Negative 2 plus 2 is 0. So this just equals x. So I know that yes, they are inverses. Because it equals x. Okay, so if you know this property is true, you can always check to see if that's the case, and that's a great tool to use. Okay, last page of the whole stinking review. Let's talk about these two using function composition. I'm going to ask that you do this one on your own, because you will never learn anything unless you try. Okay, so that one's for you. Number 21, I will do with you, mostly because I'm sick of making this video. Okay, if here's what we're looking for: f of g of x equals x. We have to see if that's true, using f of x as my outside and g of x as my inside. F of g of x. This would be equal to my f of x, my outside function, which is x squared plus 9. My inside function would be square root of x minus 9. Okay, automatically these look like inverses to me because we have a plus 9 in a square, we have a negative 9 in a square root. One fact about square roots that you should know is that if you take the square root of x squared, this just equals x, because squares and square roots cancel each other out. They are inverse operations. So this is equal to x minus 9 plus 9. The squares cancel out. Positive 9 minus 9, that gives us x. So this tells us that yes, they are inverses. Okay, last one. Don't pause it now. Let's just get this over with. We're going to use this to do our final thing. Okay, here we go. Domain, our final question. The domain and range of this graph, well, it starts at -4 and it goes to +4. So my domain is going to be pretty easy to write using interval notation, using our brackets and parentheses. We have a closed dot and a closed dot. I don't see any open circles, so I already know that I'm going to be using brackets. So let's see, the domain goes from -4 to 4. So I would write it simply like that. The range goes from +4 all the way down to -2. Those are both closed circles, so I'll do the lowest one first, -2, 4. Okay, and then we have to sketch the inverse. To sketch the inverse, what we can do is we could switch all the coordinates of all the points, or we could just reflect it over the line y equals x. We know that works as well. Since my ruler doesn't look like it's about right, I mean, I guess that works. Let's see. We're going to find out together. Let's draw a little line. Okay. We're going to try to find the inverse, and it should be symmetrical about that line, but we can just switch all the coordinates. This point, 2, 2, is going to be the same. We can look at this point right here, 4, 5. I'll do this one as an example, and then I'm going to kind of run through the rest. 4, 5, that's going to give us 5, 4. So we go out to 5, go up to 4. There's the point right there on my inverse function. For my inverse function, I'll try to do all my points in red. Let's see, we have 3, 2, so that'd be 2, 3. The crosses over here, we'll connect the dots. We have 2, 2, which stays the same on my inverse. We have 0, 4, which is going to be 4, 0, otherwise known as right here. I'll draw that line. -2, -2 is going to be the same for both, so we have a connection there. And then -4, -1 be the same as -1, -4, which would give us a line right here. So not the most perfect drawing, but you can see that it does reflect over that line. It's just a sketch. It just says sketch, so it's fine. It's fine. Don't make fun of me. The domain is going to be the opposite of the, it's going to be the range of f of x. So once again, we have f inverse of x versus f of x to start with. It's going to have the opposite. So the domain is now going to be -2 to 4, which we can see on the graph because it goes from -2 to 4 with a bracket. I don't know what's wrong with me. And the range is going to be the opposite. It's going to be from -4 to 4. Is the inverse a function? No. I can tell right now that it's not because it doesn't, I mean, I can draw a vertical line right here and it will pass the vertical line test. But it won't right here, okay? It fails the vertical line test. If you can draw a line anywhere and have it cross more than once, that is a failure. So it fails the vertical line test. Fails the V-line test. Now you better not fail your test. So study up. I hope you took good notes. I worked really hard to make this video for you, so I hope you paid attention. Okay, good luck and have a good day. Goodbye.